What's going on, everybody? Welcome back to my YouTube channel. Look at this nice and beautiful question on the board that we're going to be solving. And the question says, find the value of x for which 64y to the 6 is equal to 729. Well, our first step will be for us to break down 64 and 229. So 64 can be written as 2 to the 6 times y to the 6 equal to, now 729 can be written as 3 to the 6. Our next step will be for us to apply the law of indices, which says, for example, when I have a to the n times b to the n, as long as they have the same power and are multiplying, this can be written as a times b to the n by grouping. So let's apply this law of indices to this expression here. You notice that they have the same power, so we can be able to group them like this. So this becomes 2y to the 6 equal to 3 to the 6. Our next step will be for us to move 3 to the 6 to the left hand side, so that we have 2y to the 6. As 3 to the 6 crosses to the left, it becomes minus 3 to the 6 equal to, now nothing is left on the left hand side, so this becomes 0. Our next step will be for us to substitute. What do I mean? I'll say let this expression here, which is 2y, be equal to x, so that our equation becomes x to the 6, so x to the 6 minus 3 to the 6 equal to 0. Our next step will be for us to write this expression in the form of difference of two squares. That means this x to the 6 can be written as x to the 3 now raised to power 2. Because from indices, when I have a base a to the m, and this is raised to the n, the law of indices says take the base, which is a, and multiply the powers. So m times n. So when we multiply the power here, 3 times 2, I'm still going to be getting 6. Minus, now 3 to the 6 can be written as 3 to the 3 now raised to power 2 equal to 0. So I have been able to write this in the form of difference of two squares. Our next step will be for us to apply the property of difference of two squares, which says when I have a squared minus b squared, this is equal to a plus b times a minus b. So let's apply this property to what we have here. By comparison, you notice that a is the same as x cubed and b is the same as 3 cubed. Now let's write that in this form. So this becomes a plus b, meaning x cubed plus 3 cubed, that's a plus b, times a minus b. A, remember, is x cubed minus b 3 cubed. That's it. Equal to 0. Equal to 0. So we've been able to apply the property of difference of two squares to this expression to get this. Now, our next step will be for us to apply yet another property to each of this and this. Why? because inside of this bracket, we have the sum of two cubes, and inside of this other bracket, we have the difference of two cubes. So we're going to be solving this one after the other. So we have two cases here. We have the first case, which is x cubed plus 3 cubed to be equal to 0. So this is going to be our first case. Then our second case will be x cubed minus 3 cubed equal to 0. So we're going to be solving this one after the other. But first, we're going to be starting with this. Let's do that in the next slide. Now, for our first case, so I'm going to be writing case 1 here. Case 1, that is x cubed plus 3 cubed equal to 0. Now, the property of the sum of two cubes is when I have a cubed plus b cubed, for example, this is equal to a plus b times a squared minus ab plus b squared. So this is a property we're going to be applying to solve this. So by comparison, you notice that a is x and b is 3. So let's write this in this form. So this is a plus b. A is x plus b. B is 3. Now times a squared, that is x squared. Remember, a is x. So x squared minus ab. A is x and b is 3. So x times 3 gives 3x. So minus 3x plus b squared. B is 3. So 3 squared is 9. That's it. Equal to 0. So we're going to be solving this one after the other. We have two cases here. We have x plus 3 to be equal to 0. And we have x squared minus 3x plus 9 to be equal to 0. Now, for the first case, x is equal to, when I move 3 to the right-hand side, x is equal to negative 3. Now, for the second case, we're going to be applying the quadratic formula. Here, the coefficient of x squared is 1. So our a is 1. Our b is the coefficient of x, which is negative 3. So I'm going to be putting negative 3 here. And c is the constant term, which is equal to 9. Now, the quadratic formula we're using is x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and substitute. So we have x to be equal to minus b. So minus b, b is negative 3. So I'm going to be putting negative 3 there. Plus or minus the square root of b squared, that's negative 3 squared, minus 4 times a times c. A is 1 and c is 9. That means 4 times a 1 times c 9 all over 2a. So 2 times a, which is 1. So this becomes x equal to, now 3 times 3, negative times negative is positive. So this is going to give us 3 plus or minus the square root of, now negative 3 squared is 9 minus 4 times 1 times 9, that's 36 all over 2 times 1 is 2. So x is going to be equal to 3 plus or minus the square root of, now 9 minus 36 is negative 27 all over 2. Now we're going to be doing something here. Since we have negative inside of the radical, this can be written as x equal to 3 plus or minus the square root of, now negative 27 is same as negative 1 times 27 all over 2. Now this can also be written as x equal to 3 plus or minus the square root of negative 1 times, now 27, I can be able to decompose 27 into a perfect square and another number. That means multiply a perfect square with another number. The perfect square I'll be multiplying is 9 times 3. So 9 times 3 is 27 all over 2. Let's continue in the next slide. So this simplifies into x equal to 3 plus or minus the square root of, now I'm going to be separating each of these terms, negative 1 times the square root of 9 times the square root of 3. So an expression like this can be written in this form, all over 2. So x becomes 3 plus or minus. Now the square root of negative 1 is I, that is iota, times the square root of 9. Square root of 9 is 3 times root 3. So I'm going to be leaving this inside of the radical, all over 2. So let's multiply this. X now becomes 3 plus or minus. Now I times 3 times the square root of 3 is 3 root 3 times I, all over 2. So we have two solutions for x here, which are, we have x to be equal to 3 plus, that means taking the positive first, 3 plus 3 root 3i all over 2. So this is a second solution for x. So let me call this x sub 2. And the third one, x sub 3 is equal to 3. This time we take the negative minus 3 root 3 times I all over 2. You notice that for x2, 3 is common, so we can factor out 3 so that x sub 2 will be equal to 3 is common, factor that out. So 3 divided by 3 is 1 plus 3 root 3i divided by 3. I'm going to be having root 3i all over 2. Now same for this, x sub 3 is equal to 3 is common, so bring out 3. Now 3 divided by 3, I'm going to be having 1 minus, now 3 root 3i divided by 3, I'll be having the square root of 3i. That's it, all over 2. So we have 3 solutions for this first case. Now let's see the second case. Here for our second case, x cubed minus 3 cubed is equal to 0. Let's solve this real quick. So for our case 2, we have x cubed minus 3 cubed is equal to 0. So our first step for case 2 will be for us to apply the property of difference of two cubes. For example, when I have a cube minus b cube, which is difference of two cubes, this can be written as a minus b times a squared plus ab plus b squared. So we're going to be applying this property to what we have here. And by comparison, you notice that a is x and b is 3. So let's substitute that here. So we have a minus b. Remember, a is x minus b, b is 3, times a squared, that's x squared, plus ab. Remember, a is x and b is 3. So x times 3 is 3x plus b squared, that's 3 squared, which is 9. And this is equal to 0. So we've been able to write this in the property of difference of two cubes. So we have two cases here. We have this first one, which is x minus 3 to be equal to 0. And this other one, which is x squared plus 3x plus 9 equal to 0. Let's solve these cases one after the other in the next slide. Now for the first case, let me call that case 1. X minus 3 is equal to 0. So the value of x by moving negative 3 to the right hand side is equal to 3. Now for our second case, let's call that case 2. That's x squared plus 3x plus 9 equal to 0. We're going to be applying the quadratic formula to solve this. So a here is equal to the coefficient of x squared, which is 1. B is the coefficient of x, which is 3. And c is the constant term, which is 9. So let's substitute that into this quadratic formula. X equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So by substituting, we have x to be equal to negative b. So negative b is 3 plus or minus the square root. B squared, that's 3 squared, minus 4ac. 4 times a is 1, and c is 9. All over 2a, that's 2 times 1. So this simplifies into x equal to negative 3 plus or minus the square root of 3 squared is 9 minus 4 times 1 times 9 is 36 all over 2 times 1 is 2. So x will be equal to negative 3 plus or minus the square root of 9 minus 36 is negative 27 all over 2. So I'm going to be leaving out some steps here. This is x equal to negative 3 plus or minus. Now, from our previous solving, we saw that the square root of negative 27 gives 3 root 3i, right? Cool. All over 2. In case you forget that, you can go ahead and watch that. Now, we have two solutions here. We have x. Remember, we've already got 3 solutions before. So this is going to be, okay, that makes it 4 since I have here. So this is, we have 4, and this is 5 and 6 solutions of x. So for the 5 and 6, this is equal to, now notice that 3 is common, so I can factor out 3. Now, negative 3 divided by 3, I have negative 1 plus or minus 3 root 3i divided by 3, I have root 3i all over 2. Now let's separate the fifth solution of x from the sixth. So for the fifth solution, I'm going to be picking the positive. So I have 3 times negative 1 plus the square root of 3 times I all over 2. Now for the sixth solution of x, which is x sub 6, this is equal to 3, negative 1. This time I'm going to be picking the negative, which is minus root 3 times I all over 2. So you notice that I have 6 solutions for x. But the question requires us to look for y. So x is just a substitution. So let's go ahead and look for y in the next slide. Now, these are all the 6 solutions of x that we have solved. Now, to look for the value of y, we're going to be recalling. So recall that we said let 2y be equal to x. But since we're looking for y, we're going to be dividing both sides by 2. Divide both sides by 2 so that 2 cancels 2. We have y to be equal to x over 2. Now we can use this to solve for all 6 solutions of y. So for the first one, y sub 1 is equal to, this is when x is negative 3. So this becomes negative 3 over 2. Now for the second solution, y sub 2, this is equal to, this is when x is equal to 3, which is this expression here. So y will be equal to x is 3, times 1 plus root 3 times I, all over 2. Remember that this is divided by 2, so we're going to be dividing this by 2. So that the second solution for y now becomes, now these 2 here and these 2 are going to be multiplying since both are denominators. So 2 times 2 gives 4. So we have 3 times 1 plus root 3i all over 4. So this is the second solution for y. Now the third solution for y, this is when x is equal to this expression. So this is equal to x, which is this expression, 3 times 1 minus root 3i all over 2. Remember, this is divided by 2, so divide by 2. And this will give the same result like this. So y sub 3 will be equal to 3 times 1 minus root 3i all over 4. Now, the fourth solution for y, this is when x is equal to 3. So this becomes 3 over 2. So 3 over 2. Now, the fifth solution for y is equal to, so this is when x is this expression. And if x is this expression, it will look like this, right? Cool. So we're going to be having something that looks like this. The only difference is this negative 1 inside. You see? So y sub 5, which is the fifth solution for y, now becomes 3 times negative 1 plus root 3i all over 4. Now, the sixth solution will look exactly like this. So this will be 3 times, this is when x is this expression here. So I'm going to be having something like this, 3 times negative 1 minus 3 roots I all over 4. So these are the 6 solutions for y. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.